Our last subject is gears. Gears, most gears are standard parts that you just need to know how to select them. And there are certainly some special gears that are like especially big, extra size, and those are special gears. Now the common gear is something we call the spur gears. Spur gears. And those spur gears is a round disc that has teeth. And this spur gears. Certainly besides spur gears we have some other type of gears too, like worm gear and which unfortunately we probably don't have time to talk about it anymore. So the spur gears is what we're going to talk about here. Now when the gears, the function is to transmitting power and transmitting power from one shaft to another shaft while change the speed and change the direction of rotation. Okay, so it's transmitting power, but change speed, rotation speed, and change directions. It can change that of rotation here. Now, when you talk about that, then for a gear to work, you got to have a pair of gears, or more than a pair, or two or more, like 3 gears together, or something like that. Now, when you talk about a pair, let's say if you have a pair of gears, if you have a pair of the gears here, a big one and a small one, and then there's a teeth here, there's a teeth here, there's teeth here, there's teeth here, there's teeth here. And this one here, we gave a name. The big one we call gear, and the small one we call a pinion. Small one we call a pinion. Okay, big one we call a gear. And then when we select the gear and the pinion, we have a certain formulas that we do, and then we use a small p to indicate this is the pinion. We use a small g indicate this is gear. Now let me ask you a question. You can email me the answer if you know it. What's the bigger one we call the gear? What's the biggest? The biggest gear. If you know the answer, you can email me, okay? If you know the answer, you can email me. So, now let's say if this one rotates and this one rotates here, and we will have a rotation speed. Let's say this is W omega P, and this one is omega G here. And we will have this relation omega P, that's a pinion, omega G, omega means rotation speed. That's a rotation speed. And normally it's in the radian per second, in the units of that, radian per second. And this is going to be proportional to the diameter dg, reverse proportion dp here. Okay, again, there's a subscript g and p represents gear or pinion. And this negative sign here means the direction of rotation is opposite. Okay, so directions of rotation, opposite. So that's a negative sign over there. But this just indicate directions. It does not involve in the calculation. So from now on, we're going to take the negative sign out. We just say, okay, omega p over omega g is equal to dg over dp. Here, dg over dp. So we have this relation. That's a basic relation here. Now, if you take a look of, let's say if we enlarge a gear, and that's gonna be our teeth here, and then in the middle of the teeth is where the other one from the pinion goes in here. In the middle of the teeth, and we call this circle here, pitch circle. That's what we call it. Alright, so the pitch circle. Now, no matter how big is the gear, how small is the pinion, the teeth has to be the same. So teeth on gear and the pinion, shape and the size will be the same. Gear and the pinion, shape, size, same. If it's not the same, they're not gonna mesh. They're not gonna bite each other. You're gonna have a fight over there. So they have to be the same. So to indicate that, we call it pitch has to be the same. Pitch, same for a matching pinion and gear. Here. So that's a pitch circle. And then when we say there's a DG and a DP, this is something we call pitch diameter. Okay, that's what we're talking about. Pitch diameter. So now the pitch, the complex thing here is that we have two units. We have standard units and we have metric. So we have two systems we're going to work with. We have two systems we're going to work with. A pitch in metric is actually the distance between two adjacent teeth, okay? Two adjacent teeth on the pitch circle, So that's the definition of pitch. But for standard, it will be different. It will be so this one here we use lowercase p here. Standard we use a capital P here. Pitch, the definition is number of teeth on the gear per inch of pitch diameter of that circle, per pitch diameter. Okay, so definitely in metric, we know pitch is equal to pi d, whether it's going to be pinion or gear, divided by n. N is number of teeth. So because it's a distance. Standard inch system, pitch, you'll see I use capital P here, use a lowercase p here. This is equal to N divided by D. Okay, that's the diameter. So that's a difference. That makes things really complex, isn't it? We're going to have a lot of formulas here. And so this is one here. Now, also in the calculation, normally we don't like this omega, which is rotation speed. Omega is equal to 2 pi divided by 60 times RPM. And instead of RPM, we use the book uses W instead of omega. The book uses W representing RPM. W representing RPM. So apparently we will have WP over WG is equal to DG over DP. Okay, doesn't matter whether it's metric or standard. Now metric, you have P, pitch, equal to pi D. If it's you are talking about the pinion, then it's pi dP over NP. If it's gear, then it's pi dG over NG. Okay, so we're gonna have either pi dP over NP, N is number of T's, or pi dG over NG. Okay, and then standard pitch is equal to N over D. Okay, again, you can have NP over DP or NG over DG. Now, this has to be the same. Those two has to be equal. Equal here. Otherwise, we're going to have a problem. Okay, remember that. Those two have to be equal. And from that, if you substitute this one in here, and you'll find out actually WP over WG is equal to NG over NP. So reverse proportion to number of T's. All right. And now, since it's standard, this page on the book, there's a chart like you have pitch equal to 1, 2, 4, 6, something like that for standard, and for metric you have like 0.2, 0.4 millimeter, something like that. Okay, let's take a look at an example. If we have, let's say, if we have a pair of gears, the center distance C, you have a pair of gears, and then the center distance we call the C here. C, that's a center distance, and the C is equal to half of dP plus dG. And let's take a look at example. If we have a pair of gears, so a pair means you have a pinion and a gear, and the center distance is 130 millimeter. Okay, so that means we are dealing with metric. And now we're dealing with metric. Now, when we're dealing with metric, there's another term we need to introduce. Another term we need to introduce is something we call there's a pitch. It's something we call pitch module. Okay, metric. We have another term we call pitch module. That is M is equal to D over N. So this pitch module, you can have dP over NP. It should equal to dG over NG, because otherwise it's not gonna mesh. For them to mate, they have to be the same. Okay, so pitch module. Now in this example, it says pitch module M equal to 2 and reduction speed reduction equal to 4. Speed reduction, normally we say speed reduction equal to 4. That means it's omega P over omega WP over WG RPM equal to 4. Okay, equal to 4. The smaller one rotates faster. So that's gonna be the problem, and we need to find out what's the diameter. So we need to find out what's the diameter and how many tooths. Okay, the diameter, what's the size of the gear and the pinion, and how many teeth on each one here. So we need to find out dP, dG, and NP, NG. We need to find out that. So if you know that, for example, you say, oh, I have a 36 teeth, 36 number of teeth, 36, I have a pitch module equal to 2. A guy will find out a gear for you right away. Okay, we'll find out a gear for you right away with those numbers. But you need to have two numbers. You need to have either the pitch module or the diameter, or if you have a diameter or the number of teeth, we can specify a gear. You got to have two numbers to specify a gear. So that's the problem. The center of distance is this, and then the pitch module is this, and the speed reduction is this. And we need to find out those numbers here. Okay, so that's what we're going to do. We're going to write out all those formulas. So this formula, the center distance, dP plus dG, and that's equal to 130. And then we have dP over NP, that's equal to 2. dG over NG is equal to 2, because they have to be the same. And then we write out this one here, WP over WG, that's equal to 4. We know that's equal to either one. You can write it down as dG over dP equal to 4. Or you can say just NG over NP equal to 4. We have this formula. See, this is a formula. There's a formula here. We have this formula here and here. So you can use either one. Just use one, don't use both. Okay, just use one, don't use both. Let's say I'm going to use this one here. Alright, so if you use this one here, and you can find out from this one here, from this formula, you can find out dG is equal to 4 dP. And then you put this formula into this one here. into this one here. So you have half of dp plus 4 dp. That's equal to 130. Then you find out, well, dp is equal to 260 divided by 5. And we find out where is I didn't do the calculation, but 260 divided by 5, so that's gonna be, now how much is that? 5, 20, and 10, 52 millimeter. Okay, solved one, and then you plug in back this one here, dg is equal to 4 times 52 equal to 208 millimeter. Okay, so problem solved here. Now if you plug in here, dp is 52, np equal to 2. So np you put np over this here and put 2 over here. It's 52 divided by 2, you have 26. Number of teeth on pinion is 26. The same thing you can do it here. So 208 ng is equal to 2. So ng is equal to 104. Is that right? 104. Yes. Okay, so problem solved. I will have some problems for you to solve, and I'm gonna make because the book is playing tricks on us. It says available on the book's online resource. I don't know if you have online resource access, but anyway, I will make a copy of those problems and email you. Okay.